skeletal structure of the muscle, and we have seen the process of the contractile process that we are having at skeletal muscle. Okay, we said we have interaction between thick and thin filaments, and by that interaction, of this interaction is leading calcium ions, okay, to get the displacement of tropomyosin away from the binding sites over actin molecules. And we have this process. We said we have binding first, then bending or power stroke, okay? Then we have process of detachment. The detachment, we have decreased affinity actually between the binding sites, and that decrease in affinity has taken place by replacing ADP, okay, with an ATP molecule and dephosphorylating the head, okay? So we are re-energizing that head by phosphorylation by the activity of the ATPs. Do you have questions? Questions? Okay. Questions? No question? Nobody has asked about magnesium. What's the role of magnesium? And? حكيت عنه؟ Okay, مجموعات ثانية ما Okay, so you know now what the role of magnesium is needed for the ATPase activity and to build the phosphorylation actually of the head. Okay, and to get re-energizing process. Okay, so we'll continue. You can see more details about this lecture in this link if it's working. I haven't checked actually recently. Okay. Now we are starting with muscle energy. You know that for the process of contraction we have needed ATP molecules. Okay. In addition, for what other processes we are needing ATP? What are other types of processes that we are having at the muscle and needing ATP? Like what? Are you having action potentials at the sarcolemma? Is that needing ATP? To keep low concentration of sodium inside and high concentration potassium inside, you are also needing ATP, exactly. So we have a lot of ATPase pumps, sodium potassium pumps, which are also needing ATP. Now, for the process of contraction, you have needed calcium. How we are reducing calcium concentration inside the muscle during relaxation? You have a lot of pumps at the level of sarcoplasmic reticulum, which are pumping this calcium back to this compartment, okay? Also, you are needing these macroenergetic molecules. So we have a lot of processes which are needing macroenergetic molecules. The ATP, which is found in the muscle, is enough for a few seconds. After 5-10 seconds, you are consuming all ATP molecules. So the muscle has to stop work? No, okay? We have another macroenergetic molecules where we have stored energy which can replenish the consumed ATP. What is that molecule, which is macroenergetic also, is the creatine phosphate. We have an enzyme which is transferring phosphate group. Okay, from the creatine phosphate to ADP, we are replenishing the ATP, so we can consume also more macroenergetic molecules in that way. But also, the energy stored in creatine phosphate is enough for a few minutes now. So after a few minutes, we are getting consumption even of that amount of energy for the muscle activity. Okay? So what we have to do, we have a third source by which we are getting macroenergetic molecule, which is by degradation of glucose molecule. You know, that process can need, okay, we can have degradation of glucose without the need of oxygen, in this case, which is the process of glycolysis, but this can give only few number, okay? It's not highly efficient actually to give sufficient amount of macroenergetic molecule. But we have a fourth process, which is the oxidative phosphorylation. We are using the products of glycolysis, burning these products more and more at the level of mitochondria, okay, by oxidative phosphorylation process to get generation of more ATPs and replenishing that ATP to be sufficient for muscle activities. Okay? Now, we said we are needing also oxygen. Okay? Are we storing oxygen at the level of the muscle? Are we storing oxygen? We have high store of oxygen. How? Myoglobin. Because the myoglobin is similar to hemoglobin, actually molecule. We can store more amounts of oxygen and using that oxygen for the process of oxidative phosphorylation. Now, you know that in our body we have fast muscles and slow muscles. Fast muscles are depending on which type of energy, in this case. Or something fast to get more generation or fast generation of ATP. What that? Glycolysis. Okay? Glycolysis. While slow muscles are depending more on oxidative phosphorylation process. Also, from other view for the muscle, histological view, we have red muscles and white muscles. Which of these is fast muscles? The red one or the white one? The white muscles are fast muscles, while the red muscles are slow muscles. Okay? So we have a lot of differences actually between these two types of muscles, the red ones or the slow ones. Okay, we have higher vascularization, for example, in the red muscles also, which is also can give more for the reddish color of these muscles and so on. Even our body depends on the activity of each type of muscle. We have some muscles which are characterized as fast muscles, like eyelid muscles, for example, lips muscles, and so on. Tongue muscles, they are fast muscles, okay? But we have also plenty of slow muscles, like back muscles, okay, which are depending more on oxidative phosphorylation. And I think you know that we have some sports depending more on fast activity of muscles, like running for short races, for example, 100 meters and so on. While we can have also other sports like marathon sports for long distances and so on. These people are depending more on the activity of slow muscles actually. So these people are actually trained from childhood period, okay, to get their, or during their growing period, to get more fast muscles or more slow muscles, okay, and their muscle depends on the need. You will have fast or slow muscles. So this is with regard to muscles and characterization of fast and slow muscles and the energetics of these muscles. تفضل.
كرياتين فوسفات يستخدم بشكل طبيعي ولا لما يكون في ديفيوجن؟
ايش؟
كرياتين فوسفات يستعمل بشكل طبيعي.
Yes, it is a sport. It is used all the time. The ATP in the muscle is 0 for 2 seconds only. After 10 seconds, you are consuming all ATP. So you are needing immediate source. That the immediate source is creatine phosphate. Okay, it's immediate. Okay?
مو بس بحالة انه الاي تي بي الى اقل كثير سواء كان اسبوع قبل.
So all the time we are using the exact energy stored in creatine phosphate. Not only the fast or slow, all these are depending also on the resource. Now what about muscle mechanics? Before starting talking about muscle mechanics, I think you will have in the lab also more explanation about some phenomenon or some phenomena that can be, okay, explained in from practical view with regard to muscle mechanics. But before talking about that, can we have one question? Can we have a contraction without shortening of the muscle? Are you sure? What do you mean by contraction? So the contraction, in that contraction, any contraction of the muscle, is interaction between thick and thin filaments. Okay? If you have contraction as interaction between thick and thin filaments, to say you have heads of a muscle were fixed. Okay? You have fixed that. You say this muscle. Okay? Can you contract it without the shortening process? Children, you can contract it without the shortening process. Okay? Still contract it. No shortening. Okay? So the contraction, if you are defining the contraction, is interaction between thick and thin filaments, which may result in shortening. But if you have the heads of that muscle are fixed, you are not getting shortening, but if you have stimulated that muscle, it is a contraction. Okay? Actually, we have two types of contraction. One of these types is called isometric contraction. What do we mean by isometric? No change in length. But what we are changing in this case, if we have no change in the length, and we have interaction between thick and thin filaments, we have change in tension in that muscle. Tension. Okay. So the interaction between thick and thin filaments has caused a change in tension. Can we record that tension? Yes, simply by introducing electronic transducers in the preparation that they can record the tension that can be developed in that muscle. Okay? Now, to say, you have myofibril, okay, or even one muscle fiber, one muscle cell, yeah, okay, or myofibril. You have stretched that myofibril until having no overlap between thick and thin filaments. And now you have stimulated the preparation. Are you getting any interaction between thick and thin filaments? No interaction. Are you recording any tension in this case? But the heads are fixed, so we have no we have isometric contraction in this case, but the changes will be in tension in this case. Okay, are we recording any tension that can be developed? No. So we are at this point in this case, if you have stretched the myofibril until getting the length of the sarcomere, 3.8 or micrometers or more, okay? As you see, we have no overlap between thick and thin filaments. In this case, the tension that can be recorded is 0. Now to say we have stretched, but not to that length of the sarcomere, to a lower length at that point, okay? So you have some overlap between thick and thin filaments. By this some overlap, you have stimulated the preparation, you are starting to record tension, okay? Stretched to a lower length, you have more overlap, you are recording more tension. The maximal tension that can be developed actually, if you are taking the preparation out, okay, and fixing the head without any stretch. Now, at that point, you have maximal overlap between thin filaments and 1/2 of the thick filaments, okay, in this way. So you can record the maximal tension, which is at the 2.2 microns, okay. Now to say, you have contracted the preparation before, contracting it, and then fixing the head, okay. Now you have stimulated it again to record the tension that can be developed. The tension that can be developed becoming lower and lower. Why? We have this phenomenon. Because you have now maybe some overlap of thin filaments from this side with thick filaments, or the other half of the thick filaments from the other side. This way you have two opposite interactions, okay, that are taking place, which may reduce the tension in this preparation, okay. So you are getting this curve, which is relating the tension that can be developed according to the length of the muscle, the 100% length, which is corresponding to the resting length, actually stretching more to 120 or 30% or 140%. That's resulted by stretching of the muscle, okay? Here is resulting by reducing the length of the muscle by previous contraction and so on. Okay, then fixing the head, then measuring the tension. Okay. Now, in the previous slide, you know that we have taken either one myofibril or one muscle fiber to get stretch of all myofibrils inside at that length of the sarcomere. Now, if you are taking the whole muscle, okay, stretching that whole muscle, actually, by stretch of any muscle, you are starting to record a tension by stretch without any stimulation. Now, and you can record this tension, which is in sky blue, and it is called passive tension. Passive without any activity of the muscle, only by the stretching process. Actually, any elastic element, okay, once it is stretched, it can record tension, even elastic rubber. If you are stretching it, placed with the electrode placed in that rubber, you start to record tension, which is called the passive tension. What about the muscle? The muscle is also elastic tissue. By stretch alone, you can record that tension, which is called the passive tension. Now, if you are at this point, okay, so you have the passive tension here at that point. Now you have stimulated the preparation, okay? By the stimulation of the preparation, you are recording that tension, which is the total tension. The total tension means what? The passive plus what can be recorded by the stimulation process. At this point, you are stimulating, okay? You are recording this tension. So this green line representing the tension, the total tension that can be recorded, which is the passive plus the tension that comes from stimulation process. Can you figure out the tension that comes from the stimulation of the preparation alone? Simply by subtracting this from that, okay? If you are subtracting this from the total tension, you are getting the third curve here, which is called the active tension. So this active tension that we are having here in red line, representing the tension that can be developed during by stimulation process, okay? Where you are having the highest active tension. At the resting length also, okay? So at the resting length, this is in accordance with what we have seen with a smaller preparation with myofibrils. We have the highest active tension that can be developed is at the resting length of the muscle. Now below, actually, the tension, if you have contracted before and stimulated and so on, the tension becoming less and less, actually, okay? So this is curve relating the length tension curve for the muscle. Okay, we have passive tension by stretch alone. We can record total tension, actually, which is the passive plus the tension that can be developed by the stimulation process. By subtracting the two recordings, we can get what we are calling the active tension, which represents the tension by stimulation or by stimulation of that preparation. We are calling it active tension. Okay. Also in your book, this is a slide. This slide is in your book also, which is relating the velocity of contraction, okay, with the load of that muscle. To say a muscle is not loaded, contraction. It can contract as fast as possible, actually. Now, if you are placing any load in that muscle, are you having the same velocity of contraction? You are starting to reduce the velocity of contraction. If you have loaded that muscle over its capacity, okay, over its performance, it cannot contract. In this case, the velocity becoming what? Zero, okay? So according to the load by which we are loading this muscle, we can record this curve at the zero load. We have the highest velocity, while at the highest load here, we can get zero velocity of contraction, and so on. This is a simple curve here. Okay. Now, in the lab, now we are talking about contraction with shortening. What we are calling that type of contraction with shortening. We said we have isometric contraction, and this type of contraction with shortening, now it is not isometric anymore. It is called isotonic contraction. What do you mean by that, isotonic? So we have reduced the length, but we have what's constant? Tension in that muscle. Tension is zero. The changes in tension is almost zero. Okay? When you have a free preparation, the tension which is recorded is almost zero, actually. Okay. Now, by the recording of the contractile process, what happens? We have shortening and you have relaxation. The shortening is contraction, while the relaxation that we are having is taking place, okay? لو سمحتوا please, please. Okay, so we have two periods actually. One period is called contraction period, and one period is called relaxation period. Actually, what we are recording here, time, that has taken place over a period of time, okay? And according to the speed that you are recording, the speed of the paper rolling, okay? You can get this in this way, or in that way, or in that way, according to the speed that you are recording. Now, in the lab, they will show you also at which point you have stimulated that preparation. Okay, or have we stimulated that preparation at this point? Exactly at the start of contraction? Huh? What happens at that point? At the start of contraction, what happens? What happened to calcium ion? Starting to increase, okay? So, after the process of stimulation electrically, we have needed some time to start the release of calcium. Once you have started the release of calcium, you are starting the contraction. Okay. Usually, we are Also, we can define the point at which we have stimulated that preparation at that point. It is before the start of contraction. So we are defining here a third period, which is called also latent period. What happens in the latent period? A lot of events, all events that can take place before the release of calcium has taken place during what? Latent period. Action potential, for example, at the sarcolemma, which period has taken place? At that period, okay? And so on. Okay, so at this point, at the start of contraction, we have started release of calcium. We have started to increase the calcium concentration in the sarcoplasm, okay, to get the interaction between thick and thin films. Any event happens before that has taken place in the latent period. Now, what happens if you have stimulated that preparation here again? Or here, to say. Is it contracting again? Yes. The action potential over the sarcolemma here has taken place a very short period over the latent period. Now you are out of refractory period, so at any time you are stimulating the preparation here, you can get also another contraction like this one. Okay, this is stimulus. You can get this recording. That recording is called the simple muscle twitch. One twitch only. Okay. Now, if you have another stimulus, it can give this recording. To say we have two stimuli, okay, one after another, so you have contraction, starting relaxation. Now the second stimulus coming, what happens? We are getting contraction again. You are out of refractory period. What happens if we have many stimuli coming one after another? That way. So you can get contraction without any relaxation in this muscle. And what we are calling this phenomenon, please طالع صوتكم please. إذا ما بدكم تحترموا زملائكم وأنا ما بدي أحترمكم بطلعكم برا وما ترجعوا عندي على هذه المحاضرة. Please. في زملائكم جايين يتعلموا. اللي مش ناوي يتعلم الله هو ما بدنا إياه. Okay, what we are calling this phenomenon? Tetanization. Okay? That's tetanization if you have many stimuli coming one after another. Okay? You can get contraction without any relaxation in this case. As you see here, also this slide, up and down, is the simple muscle twitch, but we are recording at much lower speed, actually, of the running paper. So in this case of getting the curve this way, we are getting the curve up and down, only. And like one line, actually there are two lines, okay? One during contraction, one during relaxation, and so on, okay? Now what happens if we are continuing stimulation of that preparation? That's in the lab. Electrical stimulation. You have high frequency of stimuli. Are you getting that tetanization or the same strength of contraction for days or weeks? Huh? Start to decrease, as you see, and returning back towards zero. That's zero. Okay, you have started the baseline here. That's the same baseline. What we are calling this phenomenon, that's the fatigue. Okay? That's the fatigue. What do you mean by fatigue? What happens in that preparation? Don't forget, we have stimulated electrically the nerve. Okay? The nerve. You have stimulated the nerve electrically, which is innervating that muscle. The muscle responses in that way. Okay? So we are getting tetanization, but with time we are getting what we are calling the fatigue, returning back to the baseline. So that means there is no more activity at the level of that muscle. What happens in that preparation? ما قدر يعمل ديبولاريزيشن، ما دام ما قدر يعمل ديبولار ليش ما قدر يعمل؟
يستمر الايونز لسه ما يقدر يرجع.
Okay. If you have placed electrodes over the sarcolemma, okay, you are getting normal contraction again. But if you have stimulated the nerve preparation, you are getting no contraction in that muscle. So what happens? Stimulation of the nerve, no contraction. Stimulation of the muscle directly, electric contraction, full contraction. What happens?
receptors يعني بتصير المصل والنيورون ساينابس
Exactly.
بطل يوصل النيورو ترانسميترز للمصل فبطل يصير
شو صار المشكلة هناك؟ مضبوط على النيورو ماسكولار جنكشن المشكلة.
ما هي عشان يطلع نيورو بطل يطلع نيورو ترانسميتر كأنه
طيب by each stimulus you are consuming neurotransmitters صح ولا لا؟ After this high number of stimuli, what happens to the neurotransmitter? We are getting depletion of this neurotransmitter. By depletion, you are having no transmission at the level of the neuromuscular junction. So the fatigue in this case actually is at the neuromuscular junction. That's the fatigue. Okay? At the level of neuromuscular junction, we have the fatigue itself. But in our daily life and the sportive people and so on, they are calling the fatigue in vivo. We are talking here about in vivo only, okay? In vivo, when there's muscle problems, okay, related to high activity of the muscle, which may develop pain and so on at the level of the muscle. But actually, that's not a true fatigue. Actually, that happens because of high accumulation of lactic acid. You know, the process of glycolysis is followed by oxidative phosphorylation in muscles, which is needing oxygen and so on. And we have in between lactic acid taken, okay, or lactate taken for further processing at the level of the mitochondria, and we have some needing more time actually, but the production of these lactic acid high results in accumulation, which results in changing pH, changing activity of the muscle. This may result in muscle spasm and pain, okay? Actually, some they are calling this type of muscle weakness or muscle problem related to the high accumulation of lactic acid as fatigue, okay? Well, but the fatigue, the real fatigue is by having no response of the muscle because there is no transmission from the nerve to get the muscle. Direct stimulation of the muscle is the muscle is still functioning, still contracting without any problem. Okay? In vivo, fatigue can happen. It's actually when there's nerve cut. No more transmission of the stimuli from the central nervous system toward the muscle, which is like paralysis of these muscles, which may result also in fatigue, okay, of these muscles. Okay, so this is, we have one thing also over this slide you have to note, okay, with regard to this recording. As you see here, that's the amplitude after first stimulus, okay? Now the second stimulus coming, giving the same amplitude or higher amplitude. Higher amplitude. Third stimulus giving even higher amplitude. Okay? What happens? What that means? More shortening in the muscle. Why we have more shortening in that muscle after the second, third, fourth, fifth?
It's already there's a lot of nation.
Not contract. You are getting full relaxation as you see. You have full relaxation back. What we are calling this phenomenon, is it a summation? What we have here actually is called summation. Even the totonization is called summation. It is a wave summation. Here It is also called wave summation. Okay? Is that a summation? No, it's not a summation. It is called trip phenomenon or staircase effect, like stairs. Okay? Why we are having that? This is staircase effect. Why we are having it? Yes. The amplitude of contraction depends on what? On what depends? On the strength of stimulus? You have the same strength. Concentration of what? Of calcium inside this. Now, after first stimulus, okay, you have increased calcium concentration from 10 to the minus 7 to 10 to the minus 4, for example. Now, that's very short time between the stimuli. Have you pumped back all this calcium or this sarcoplasmic reticulum? No. Okay? So now the second stimulus coming, causing more release of calcium. So this will increase also calcium concentration inside the muscle. Third stimulus coming, higher calcium levels, and so on. Anytime you have higher calcium levels, you have higher probabilities for activation of troponin Cs and higher interaction between thick and thin filaments, which is reflected here by higher shortening actually or higher amplitude of contraction. How many ions of calcium you are needing?
4.
To get activation? 4. Okay? So with increasing calcium concentration, you have higher probabilities for more activated troponin Cs and more shortening in that muscle. So the amplitude of contraction actually depends on the concentration of calcium. Hold on. سامع. ايش سؤالك؟ Okay, but at the level of the muscle, actually we are not having that low concentration of calcium because the only source for calcium is from the spine. But it's a good question. What happens if we have in our body low concentration of calcium? What we have in our body, if you have in our body low concentration of calcium, what happens? If we have low concentration of calcium, what happens? In our body. Smarter with tetany. Okay? Tetany. Because that can happen because of the low concentration of calcium, contractions of the muscle spasm. Okay? Why we can have that? Lax has okay. Okay, why we can have that? Okay, you remember what we said yesterday about the motor neurons? What we said, we have more inhibition rather than excitation. Okay? More inhibitory synapses rather than excitatory synapses. Now, by low concentration of calcium, what happens? Are you getting chance to get higher frequency of getting pulses or muscle or action potentials or lower frequency? You have more inhibition rather than excitation. Now, what's the role of calcium? Causing what? Release of what? Neurotransmitters. If you have reduced the release of inhibitory neurotransmitters, what happens? More excitation. That's what happens. Actually, the hypocalcemia, okay, can induce tetany or muscle spasm by its effect over motor neurons, okay? We are getting more release or more activity or more action potential generated at these motor neurons, which may result in muscle spasm. The problem is there, not at the level of the muscle. The muscle is responsive. Okay? I hope it's clear also. Any question? Okay.
طيب يعني الكالسيوم مسؤول انه يطلع بس الامتحان
Yes. Okay. Now. فاهمك هذا النقطة. لنفرض انه 80% من الساينابسز are inhibitory. Okay. عندك 20% they are excitatory. أنا لما قلت once you have lower calcium concentration, okay, you have reduced both by 10% to say. أنا 10% من 80% نزلت ل 70. هذه نزلت فقط 2. اوكي excitatory. فصار dominating excitation. بس. Yes. Okay. Any question?
Yeah. In case of saline gas, it would be fatigue or
بس لو سمحتوا انا نسيت وقت الحضور غياب طرف كل واحد يطلع ورقه يكتب لي اسم ومررها على السطح على طرف كل واحد من الطرفين الثاني. لو سمحتوا ما كملنا تستعجل وين؟ بعد نطول. لا بدي ورقه تكتب حضور غياب. So what we are calling that phenomenon, we are calling it as trip or staircase effect, okay? Until now we have seen with regard to muscle mechanics, we have seen the wave summation, tetanization, which is sort of the wave summation. We have a second type of summation, which is called motor unit summation, okay? Motor unit summation. Listen, please. If you have questions. ما في أسئلة? Okay, next time we'll continue with the wave summation with the